Another important component of ROS systems is services. People use it a lot. They are really useful. They can be used for synchronous communication. We are going to be understanding services in 3 different steps, starting from creating an empty service, then ROS Wiki addition service, and at the last we are going to be creating a service that increases the velocity of the robot. So let's start with the first one. I will be first going into the package workspace, R1 Wiki workspace, and inside of it there is a source folder and there is ROS1 Wiki repository that I am publishing on. First I am going to create a package. Catkin create a package service package. std messages and rospy is the dependencies, and then catkin make. This adds up the package into my workspace. In service package, I will be creating a folder. All of the services that we will be creating are going to be stored here. Before creating the scripts, you need to understand one thing. Services have 2 components, a server and a client. A client can be the terminal or a script, but server should be defined like a node. Let's see how does it looks like. So first let's create a empty server.py. This is not going to be an SRV. It's just an empty server requesting and responding. There is not going to be a client as well. I am going to go into the ROS tutorials that we are following, and currently this is what we are looking forward to, writing a simple service and client. We have an example implemented here. We are going to be using that example in the next step, but the code is going to be utilized in this first as well. So let me simplify this code so it becomes more readable and understandable. So at this specific point, you can see I have simplified the code to an extent. Only this node is initialized and this service is initialized and it spins. What it does whenever I call, it's exactly similar to nodes, that you define a node and in that specific node you provide the topic and then you provide the data type and the callback function, or I should say CB, empty response callback. This print service is going to be the service available. This is the data type we are using. I'll explain what this data type is. So let's first see what this data type is. If I say ROS SRV list, it provides me all available services I have. Okay, I am currently interested in ROS service SRV show a standard message service, and that is an empty service. I'm going to press enter and it actually contains nothing, no request, no response. And what is request response, I'll explain later. For now, to understand it, let's run it and then we'll see what changes can be made. And keep in mind that this is a node. Okay, we have to make it executable. Let's go into this package, service package, ROS CD service package. Inside of that we have a source folder and here we have to make it executable. Now it's executable. ROS run service package empty server. It says no ROS core. ROS core is now running. Let me create a logger, rospy.log info, or we can say log warn. That becomes a yellow text. Warning is starting empty server. That's just going to tell us that this node is running or not. Starting an empty server. It should have been yellow because of the log warn, but the server has been started. Let's now open up another terminal and I am going to call this service ROS service, the full name, call, and what are the available services. I think the name is print service, and press tab, it automatically completes, and press enter. So what happened? This was the client, this service was executed, and we just saw that just receive a service. So this function was executed. At this specific point, you might be thinking services are useless and they are no different than nodes. But this is the process I thought the best it could be. You can run a simplest service and then you add nodes into it and make it useful. So let's now add a command velocity topic to drive the turtle and you use it with the help of service. Let's see. So here I am going to add a publisher, pub dot pub is equal to rospy dot publisher, and that publisher is going to be publishing on turtle1 command velocity to drive the turtle bot. The data type is going to be twist, and we are going to say that queue size is 2 messages on each call, or buffers you can say. So 2 messages can be queued. We have to import the message type from geometric message dot message import twist. Then the next step is to define the message. We are going to say velocity message is twist type, and you are going to loop it. We can say for I in range of 10, we are going to be sending the velocity message pub dot publish and velocity message. It is going to be sending in this loop, while this loop is running, the velocity message. What we can add here, the values into the velocity message. Vel message dot linear dot x is equal to 1.0, and we are also going to add an angular, so the robot rotates, it does not go straight, and we don't want it to hit the wall. So 0.5 and 1. Then you are going to be continuously publishing, and obviously it's going to be inside the service. It is going to be called only once, but it is going to create some serious things. First we need to run the turtle sim node. It's running. ROS run. What is the name of the node that we have that contains the empty service? First the package, service package, and it's empty service. Let's see. And you can see the turtle did not move. The problem is we have to send the message not very fast, but once a second, because the computer can calculate this loop 10 times within a second. So that's the problem. We have to say there is something known as rate is equal to rospy dot rate, and the rate is 1 second. We are going to say here rate dot sleep. Whenever you enter this for loop, you're going to sleep for 1 second, then you are going to be sending the message. So we need to open up a client that is going to call this service. So we are going to say ROS service call, name of the service is print service. So I'm going to press enter, and you can see the turtle has started to move. This is moving because of this loop, and once this for loop ends, it is going to print out just a service here, and that's it. Things are done. A has been printed because of something that I saved, and I am running the previous server. So our empty service is making the robot move in a circle. The point that you need to understand here is there is no defined service. You're using a predefined service for now. But the point is you call a service, robot moves, and then the service ends. You cannot send another command while this service is executing. That's the flaw of services. They are synchronous. But on the other hand, they are useful as well. I want this job to be done. You call a service and the robot starts that service. Once it's done, it returns. That's the behavior of services. And now let's move to ROS WIki addition service. Then we will apply robotic touch to it. Let's now go to the ROS Wiki, and we have write a simple service client Python. We are not creating for C++ for now. Here we have two codes. One is a server, one is a client. I'll copy this, create a new file. I'll just copy paste this file 2 times because I don't want to make it executable again. I am going to say addition server, and this is going to be addition client. This code is for the server and Python 3, and for the client we have this code, client. Let me make it simpler so we can understand it more easily, then we will have some discussion about it. At this specific point, you can see that I have simplified the code to much extent. Let me bring it down, and the below one is the server, the upper one is the client. One thing that is remaining in terms of the files, we have to have this SRV file that is mentioned here, you need to understand how to create SRV. It's not very difficult. You just need to create a file, and I am going to bring in from this point SRV, the folder that we created SRV here. I am going to say new file edition.srv. I'm making some changes here, so you can go to this wiki tutorials and see what are the changes and compare them. This is the content. I'm going to say this one is X, this is going to be Y, and sum, or I should say result. This is the change that I'm making in the SRV. Now I have to bring in this SRV into my code. From code perspective, just completing thing, because one step is still remaining on the compilation side. From what is our package, learn service dot srv, import what is the name of the file, edition, and that's it. Then there comes an edition response. Same should be imported inside of here. We don't need this thing. And here we are. Request and response are added. There are additional things that we have to do. We have to replace that service and client both are not going to be using add to end service, because we have named the SRV file as edition. Okay, so the service is going to be the same, no problem. It's not going to be add to ends response, it's going to be edition response. I'm making the changes for your understanding so you can generalize. There are two steps that we have still to do, and those are package XML changes. They say that you need to add these two lines into your main package XML. This is our package XML. And if we go down, you can find these two lines here, but I'm going to just copy them and paste them here, and they are going to be added. These are two lines that are to be added. The next step is, they say, in your CMake file, let me bring them side by side. In your CMake file of the package, they say you need to add message generation here. Message generation is going to be added into the find package. Then comes your services part, where it is. In services, you need to define what is the name of your service. Here specifically, we don't have service 1, service 2. We have edition.srv. This is the name of our service. And that's it. Just we need to now compile. The compilation process is simple. You need to go inside of your directory of workspace and perform cat-kinn make. You will see the changes here. Once the workspace has been compiled, for mine it took a lot because I have multiple packages here. You can see your service in this manner. ROS SRV show name of the package, and it says you have an edition service. I press enter. It tells me that this is the request and this is the response. But at this specific point, it does not make any sense. What is a request? What is a response? For us, it's only two numbers, and the result is again a number because of the integer data type. But we have to create a sense of these things inside of the server, not the client. Let me show you. Here, to understand it first, let's run these and see what happens. But before running it, we need to add a print statement to actually see the value. As the structure was written in a way that it was being called somewhere, we don't need to call it now. We are going to just say print the request.sum. But it is not going to work. Let me tell you why. First, we are going to run the server, ROS run. The name of the package is service package, and the server is edition server. So let's run it. But before running, I want to clear a mistake, and that is, first I want to change the name of the package that I am using. It's service package. It's not a learn service. And there is one more thing that we need to do. There is one last step that we have to do in this CMake list, and that is to activate this generate messages. And this is one of the most important steps for generating messages as well as the services. It is all explained here why we need it in this ROS wiki point. Create a ROS message and service. And now you can see at the end it has printed out service package generated message by and all that stuff related to our addition service. Run it. ROS run service package addition server pod. This server is now running. We need to call the client. Let me open up another terminal, make it bigger. ROS run, because it's a node, so ROS run, and we are going to say ROS run service package addition client. It required some additional arguments 1 and 2. Press enter. Now here we have a mistake, and that mistake is really useful for you to understand services. The mistake is very simple, by the way. Whenever the service is showing us the mistake that addition request object A we have no attribute as A, because if you can see in the service file we have X and Y, but in the service point in the server of the service we have request A and B because we copied it. And this is important, and you have to understand it. The variable names that we are using in this SRV file, they should be the same here. Okay, so now we have to change this as well in the client because we are accessing it, and now it should work. So we have made changes here. We are going to clear this up and run it again. So it goes for, let's bring the client back, clear this client, run it again, and it prints out 3. 3 makes no sense, right? But it actually does. 3 is the response from the server, request X and request Y, and it returns the result, and this result has been printed. One thing that you need to understand on the client side, the service side is really easy, you can understand it, but on the client side you need to understand that this line actually waits for the server. Once we obtain the server that we want to talk to, this is the handle that we have created, meaning service proxy is sort of a point which you can use to enter the service. Okay, add to end service handle has been created, and in that handle we provide 2 values. At this specific point, it doesn't matter if we say A, B, C, it doesn't matter. That matters on the server side, because when we are using the request and response things of the server, we then have to be accountable for the variable names. We send these X and Y and we get the response out of it, and then we get the response in the form of result that we have defined here. Okay, these 2 are request, this one is the result. On the server side, it is upon us. We add it, we subtract it, it is totally upon us. It doesn't matter here. Okay, in the code, what is the logic we had? We just need to represent it in a proper way that this name is defended in that manner. And now I think you understand what ROS Wiki tutorial was written about on the main page. You understand responses and requested to a certain level. Now I am going to present you an example where practically you can use request and response for your own application. We are obviously going to drive the robot, but with our own custom service that is going to make your understanding more strong. Let's see. So if we take a look on our servers and clients, we need to create our last server and client. Okay, or I think we just need a server. So I'm just going to create a server here, and I'm going to name it to be velocity control node. And this is going to be a node because it is going to be containing publisher as well. If we go into our learning package, we created a node that was turtle sim saver. I'll let you know what it does. Paste the code here. What it was actually doing, it was saving the robot from not hitting the wall. We don't need this code here, and it is written in an object oriented format, class format. We are just going to be using this velocity message to make our turtle change its velocity. I am going to create another service, and that is going to be velocity SRV, just velocity SRV. It is going to take in a float value, float 32, that is velocity, and there is a response which is going to be a string message which is going to just print out the message, and that's it. These are the 2 things. Request is just velocity, response is just message which is going to print out. obviously you can add more to this, but we are not going to be doing it for now. So how do we add a service into it? If you bring in the code of the server side by side, we can easily add it. First, we need to bring in this line, which is for obtaining the service. It's not going to be an empty, it is going to be velocity data type, and it is going to be velocity CB, a velocity callback. Okay, or I should say velocity change callback. That is what it is going to be mainly doing. Now we are going to say velocity change callback. There is a function and there is going to be a request of this service. This is dealing with the service. I am going to be making the change inside of my service callback, and the change is going to be inside of the velocity message that make that linear velocity to be whatever I enter. Okay, and that is going to be request. This is the important part, request dot vel. Okay, request dot velocity is going to be set to this thing, because I'm going to set this velocity message through our client, and it is going to set this to our linear x, and I think we should add a angular velocity as well, so our robot can show the difference, angular z. Okay, and similarly, once we have added it, from our side it's not yet complete because we need to add this service. Okay, from service package dot srv import velocity and velocity response. Okay, we need a response as well. For now, I'm going to say that once you have set these values of obtaining from the requests that we are going to send, you are going to then return a response, and that response is going to be a string, which is going to be that velocity of the robot has been changed. This is the name of the function, but it is saying that this is the callback function. It requires a self because now we are dealing with the class, and it is going to be velocity change service. This is the service we are now working with. Everything seems to be fine. It is changing the value of the velocity message, which is continuously being published, so we don't have to publish it inside of the service. The service is going to be just called and the velocities values are going to be changed. The message is already being published. Okay, it's not turtle saver, turtle testing. Okay, the name of the node has been changed. Now, as we have added another SRV, we need to make the changes inside of our CMake list. And here is the point that we make the change, because if you miss this step, it is not going to find out this velocity SRV. And you can verify that as well. Although it is going to show up in ROS SRV show service package, velocity is there, but we have made the changes. It's not just simple velocity, but it is not going to be available in the main code. So we need to move to R1 wiki and we have to perform cat can make. But before performing the cat can make, we have added another value, float 32 angle. Okay, we don't need to make changes in the XML. We just do this addition of SRV. Everything else is totally the same. Okay, that's one time process that we did. Cat can make. It is going to take some time and show me at the end what are the new files that are being generated. As you can see, we have some new things here, and those things are service package generation message, and something has been created. That's what it is representing in service package message. Up till now things are looking good, but what is the client? Client is going to be a simple terminal. The thing was that you need to understand, it is a node, but inside of a node there is a publisher, there is a subscriber, there is a service. That three things can be there and more, but a service and a subscriber structure is almost the same because of the callback function, it seems like, but the service has response as well and it has a request as well. There's a difference. Okay, and one most important thing about service, when they are called with the request, and once they are completed, once they complete the loop or they complete the function, the callback function, they exit. subscriber and publisher does not exist in a simple manner, but we can make the code exit by system.exit Python script. But the main working of the service is to exit after its completion. So we are now at a point that we should run it. ROS run service package velocity control node. Is there any error? No, there is no error. It is not going to be working in this manner. We have to make the turtle sim come up because it utilizes turtle sim. This is our server running. Let's run ROS SRV call. What are the available services we have? It's going to be ROS complete service, and we need to call, press tab. It automatically going to tell me what are the available services. I want to change the velocity with this service. This is our defined service. So velocity change service, and press tab. It tells me you have two options. It automatically tells me I want the velocity to be 0.5 and angular velocity to be 0.9. Let's see. And you can see it has started to move, and it is going to be continuously moving. You can see it has started to move, but the point is it is going to be moving continuously. We have not added any stopping condition. We have just changed the velocity. Let me give another velocity, and that is obviously negative velocity that I would be giving. You can see the turtle has started to move in the negative direction. The point is we are now manipulating the velocity of a continuously sending velocity node with the help of services. That's a very practical and simplest example that I can bring up that helped me understand services, so I wanted to share it with you. There are a lot of things that you can do. For example, you can use services of turtle sim as well. The main service of turtle sim is resetting it. Service call, I think that's just reset. Press enter, it resets, but the velocity is been continuously sent. That's why it is taking the velocity. There are other services as well. For example, if I want to call spawn service of turtle sim, spawn, and press tab, it automatically give me a lot of things. I wanted to spawn another turtle on 3 of x. If I bring in this 3 of x and 0 of y, you can see another turtle. So we have a lot of services inside of turtle sim, and also available on turtlebot 3, hector drone, and kuka robot. The point is you are now capable of making your own services, and they are going to be useful services with an SRV file that have a response and a request to make the node work. You can now take a look into the other services available into bigger packages, so that is going to make sense to you now, and you can manipulate them and utilize them in your projects.